name is Marta. Yeah, I'm a software engineer from YLD. What else? I should do a slide about myself. Well, anyway, I'm from Portugal. I work there. Finally, yes, last night I created a Twitter account. It was a big achievement, seriously. And what else? And I am an enthusiast about functional programming. So let's talk a little bit about functional programming and how can we apply it with React. So, okay, about functional programming. What is functional programming? Okay, first of all, it's all about functions. Is a way of programming that you have an input, you have a bunch of operations, one or more operations, and you have an output. So yeah, it's all about functions. Well, if you don't like functional programming, I am very sorry. Please ignore me. You can just Google something. What else about functional programming? Yeah, it follows the declarative programming. So yeah, you have your computations or expressions are sets of declarations understood as something independent and isolated, unlike imperative programming. Cool. About what else about functional programming? Yeah, it also avoids state changing and it avoids mutable data, meaning that everything remains, let's say, pure. And so as functions. So pure functions is also very known in functional programming. And what is this thing about pure functions? So it means that same inputs always return same outputs. For instance, I have here an example about the square number. So if I pass 3 as an input, I will always get 9 and not anything else. Okay, second example, the map function. If I take the array of 1, 2, 3, and then for each item I multiply the item by 2, so I always get 2, 4, 6, and anything else. So this means that we are not depending on variable data or global variables or out of scope variables. And there is also no side effects, right? So here, on the first example, I defined my variable x, and as default value was 2. And then if I define my square number of picking up the variable x and multiply it by itself, on the first execution, I get 4. On the second execution, I get 16. And so on. And why? Because first, I am depending on a, let's say, global variable here, or an external variable. Second, I am changing the value of it. I am not returning anything, I'm just changing the value. So this is called an impure function. So on the second example, we have another definition of square number. As the previous example, or on the slide before, we pass the x as an input and we return the result of the computation, right? We don't store it anywhere. So which means that I don't, no matter how many times I call this function with same input, once again, I will return always the same output without changing anything else. Cool. And what else do we have? Immutability. So in functional programming, object state cannot be changed once it's created. Yes, that's right. We don't want to change our objects. And if we, for some reason, need to change an object or some property, we simply create a new object. We don't change it at all. Once again, on my example here, on the map function, no matter what I put on my array variable, my function will always return a new array with a result. So my array will remain unchanged. So yeah, so far so good. But okay, this is about React, and if there is no state change, how can actually manage state on React components, and if it makes sense? Well, the truth is, yeah, we kind of can't. We'll talk about this later. But okay, we can do other things, right? For instance, we can write stateless components. So yes, we can write components as functions. So here I have my component with some props, and I just return my HTML with my props, and then that's it. That's my component. It's a function, pretty much. Very simple. So the thing is, yeah, if we don't have to manage state all the time, we can just write stateless components. Even if we define our components as classes, we can still define stateless components, right? Once again, we don't always have to manage state, which is good. What else can we do? Okay, something about functional programming is composing functions. So we call functions and more functions and more functions after functions. So yes, something very common. So here we can compose components. And how can we do it? Well, several examples. Here I'm talking about currying. So yeah, we can decompose a function taking several arguments into smaller functions with less arguments. Okay, how can this be useful? Well, this is useful, among other things, when you need to carry some arguments to other functions. And a good example of it is event handling, like this onClick function. Cool. And about currying in React, yes, so I think all of us are familiar with Redux and MobX, and yeah, every time we need to map state to props or mapping store to props, yeah, we actually use connectors, deconnect or inject. So yeah, this is a good example how we can currying with ReactJS libraries. Cool. Another thing that we can do is write high order components. So once again, something is very common in functional programming is high order functions. And yes, we can do that here as well. And we can do it also with components. So basically, a small example of this is, okay, I have a component. I need to pass some other props to my component so I can wrap it up in another component. And here's my, in this example, my wrapped component is considered a high order component. So yes, that's one of the examples. After React 16.8, we have these amazing ReactJS hooks. Okay, to be honest, I didn't work with this that much because this is quite something new with the project I'm working on at the moment. But yeah, they are pretty useful. I chose this use state and use effect ReactJS hooks. So yeah, instead of doing something this dot set state and the value and the property I wanted, I can just use the function use state and pass a default value, and I get my prop, which I want to manage state, and set my prop, which is the function I want to call when the state gets updated. And also, the use effect also works as a component did update. So every time our component re-renders, we have this console.log. Yeah, been updated. Yeah, I know it's quite useless, so but yeah, it works an example. So, cool. Okay. about immutability in ReactJS. Okay, if you think about it, every time we have React components and we need to change something first, we never change props. Props are read-only, right? As I mentioned here, all React components must act like pure functions with respect to their props. Yeah, I quoted this from the ReactJS docs, docs. And every time we change something on state, the component gets re-rendered, right? So I think it's quite safe to say that our React components are immutable as well. So there's another example of functional programming here. So yes, and even if we don't change state at all, we can just define our components as pure components. So they won't change at all. So they're quite immutable as well, which is quite cool if we are considering some performance issues, or if you want to increase our performance. Cool. Okay, I'm being quite fast. Cool. Okay, pros and cons. Okay, this is just my point of view about functional programming and ReactJS. So what I consider is an advantage is first is immutability. Why this is good? Because it avoids unexpected behavior. I mean, I'm pretty sure it happened to all of us that having some bugs or something that is changed somewhere else and you don't know, you're trying to debug and you don't know where it is and where it comes from. So yeah, if your code is immutable as possible, okay, there's no, or at least not that much unexpected behavior. Also, it's also good if you are dealing with asynchronous programming like promises or something else, because you already know that you're dealing with up-to-date objects instead of reaching an out-of-date object, because there are some promise that didn't got resolved, for instance. It also reduces complexity, in my opinion. I say that because, actually this is about component composition, I'm sorry. I mean, if we can define our code the most reusable as possible, I think your code gets less complex. So if it's less complex, and if you deal with less changes, you might improve your performance, once again, because you don't need to check and do unnecessary re-renders. And also, actually improves some performance, yeah, as I said before. Cool. And yeah, code maintenance, I think it's just easier to maintain some code where you can just isolate the pieces of code and do some maintenance, because at least you know you're changing like in one place rather than changing the same thing in everywhere. It's just easier to maintain and easier to read as well. Okay, about cons. Okay. The truth is, yes, not everybody is familiar with functional programming. And if some people that are familiar with functional programming, none of the people liking it. I experienced this in the past. So yeah, it could be a disadvantage if you are an enthusiast with FP. Also, if you need to deal with older versions of React, yes, you still need to manage some states, so you actually can apply functional programming everywhere. Also, less efficiency in terms of CPU and memory usage. Okay, this is not 100% true. Most of the times it's true. This is related to how to the implementation of mutable data. So it requires lots of CPU usage. However, nowadays we have, depending on the languages and also the compilers and the interpreters, they might have some optimizations. So this is not always 100% true. For instance, I did some tests a while ago about the map function, and I found like more performant on Chrome rather than Safari. So yes, we have some browsers that have some optimizations for this. So yeah, that's pretty much it, what I wanted to say. So yeah, thank you very much. Yeah, that's my Twitter. If you want to ping me somewhere, or yeah, you can use LinkedIn, Twitter, or just can email me. And yeah, that's pretty much it. Thank you.